function.
Okay, so we have exercises 13 through 22. Find a formula for f negative 1 of x, and that f negative 1 of x is called the inverse function notation. Great job, Hannah. Give the domain of f negative 1, including any restrictions inherited from f. And so, do you remember the 4 steps for solving?
You have to flip or make x, y.
Yeah, so let's go ahead and do this first. We're going to say y equals 3x minus 6. So this would be step 1, right? What is step 2? Yeah, so what we'll do is we're going to make the x's become y and the y's become x's. All right. In step 3?
Add 6.
Step 3 is solve for y, but Angel, okay. So we get 3y equals x plus 6. Angel reminded me of something too when he said that, but I'll get to that in a minute. What next? Y by 3, right?
Yes.
So we have y is equal to 1/3 x plus 2. So that's step 3. What is step 4?
You put the
Yeah, okay. Emily's right. So this will be our answer. Now, do we have any restrictions inherited from f? Are there any restrictions to this function?
No.
No, polynomial functions, both. So we'll say no restrictions. They say give domain. So what is our domain going to be? Yeah, domain. So Angel's right. And Angel, what you reminded me of, I'm gonna say it in a minute, but I want to go make some other thing here. What do you notice? So this is going to be our start, right? Up here, and this is our finish product down here.
You just divide by 3.
So what do you notice comparing and contrasting the start and the finish? Everything's divided by 3?
Yeah.
Okay, yeah. That's good. What else? That's a good observation. What else?
The last sign changes.
There's a sign change. Okay, very good. Good observation. The thing I was looking for is what is our starting slope?
It's the
3, right? What is our finishing slope?
1/3.
And what do these slopes, what is the relation between these two slopes?
Left across y equals x.
Well, the equation is going to reflect about y equals x, but what are these, what relates 3 and 1/3? They are reciprocal pairs. So 3 and 1/3 are a reciprocal pair. And I want to mention something else that Will pointed out that was important, is this sign switch thing, where you have this minus here and you end up with a plus down here. Now I can't guarantee that that's always going to be the case, but that's just one more thing to watch out for when you do inverse of functions. Now one thing I have that Angel reminded me of is, remember last Friday we had that baseline test, that SLO, the 12 problems I gave you to do and all that. Well, I'm going to tell you that I had 3 people in this class who got 5 out of 12 right, which was really good for not knowing how to. And those 3, Angel, Hannah, and Kayla. So that's pretty awesome. Good work. You guys knew something about inverses or whatever, because there was stuff you knew how to do, because I saw you guys working on it. You got a lot right too. You got one of those tough problems on the back. A lot of people did. Okay.
It's probably a guess.
No, you couldn't guess because you had to actually figure stuff out.
Yeah, but it was probably a guess.
Maybe, well, and then you had the theater seat rows and all that business.
Hey, was that the one that I got?
You might have been, because some people got that one.
Because I got that one. I
Yeah.
actually counted it out.
Yeah,
Carmen did.
that's good. Well, you guys really did, you guys really made a good effort on it, no less, okay?
You got it wrong. You got it.
Okay, what I want you to do is go ahead and do number 14. And a lot of people got 4 out of 12 right too, which is also really good.
I know I did.
Really, what you should have got right, if you just guessed properly, you should have got 2 out of 12 right.
Can we see what we... Let's play 0 out of 12.
Nobody got 0 out of 12.
Oh.
You want to get 1 out of 12?
Somebody did, I don't know if it was in this class.
Mine, right there.
I can look, but that doesn't matter. You guys made a good effort on it.
This is
Can
right?
we see them?
This one here,
Yeah, right there.
you got it here? You got it. Okay, Angel's working this one out here. And, let's see what we got here. Yeah.
You should check it.
Okay, I'm gonna write down Angel's answer and then see if you got it here. And Angel, I need you to correct me if I'm wrong about this. So Angel came down here and worked it all out, got f negative 1 of x equals 1/2 x minus 2.5. Is that what you got, Angel?
Yeah.
Okay, that's what you
That's what I
got.
got.
That's what you got.
That's what I got.
And it came down to 5/2, and so it's just the steps. Okay, it's just y equals 2x plus 5, x equals 2y plus 5, subtract 5, so you get 2y equals x minus 5, divide by 2, so you get y equals 1/2 x minus 5/2, which is the same as 2.5, right? Any restrictions to this? Any restrictions to the domain? No. So here's our domain for this thing right here, no restrictions, and then this thing right here. Okay, questions on that one? Emily, are you good on this one? All right. Yeah, okay. We're gonna go on to 15. Forget the math, yeah. Okay. Does 15 and 16 kind of look similar to what we were working on yesterday for a bit?
Yeah, it does.
Yeah, I appreciate you working on that yesterday. So, for this one here, would we do the same process?
Is there another step to it? Since there's... since it's a fraction.
So there's the first step, right? And what is the next step?
But change x's to 1.
So the next step is solve for y. How would you solve this one for y?
Times it by y plus 1.
Y plus 1. So we multiply by y plus 1, we get x times y plus 1 equals 2y minus 3. And then distribute. Okay, xy plus x equals 2y minus 3.
Add 3.
So add 3. Well, I'm going to leave the numbers over here So I'm just gonna bring the y's over to the left.
Oh, yeah, that's what I meant.
Yeah. So we'll have 2y, and I'm gonna subtract x. So I'm doing these two operations at the same time, you see that? So now we have xy minus 2y is equal to negative 3 minus x. And then
Then take out one.
take out y, so I'm going to move to the right here. Y times x minus 2, is that right? All right, thank you, Adam. Good work, okay. 3 minus x, and then
Divide by x minus 2.
x minus 2, so that goes out here. And so that's what we have. And then last step, we have f negative 1 of x is equal to negative 3 minus x over x minus 2. Does that look right?
Yeah.
Okay, now, can we test to see if we got this right? Because we had a lot of algebraic manipulation going on here, didn't we? How can we test if it's right? Yeah, the slope kind of. But what I want to do on this one here is I want to show you how to test using your calculator. So if we go ahead and put the first function up here, okay, alpha y equals, okay, so the first one we have here is 2x minus 3, is that right? So 2x minus 3 goes here, and that's all going to be over x plus 1. So this is our original function, right? And we graph, and this is what the first thing looks like. Okay, now if our answer is correct, and f negative 1 of x is correct, what is this thing going to look like? Okay, what it's going to look like is this piece of the curve is going to come right over here, right? And what is this piece of the curve going to do? It's going to come way down here like this. See that? So we go back to y equals, and we go ahead and put in negative 3 minus x, and all that is over x minus 2, and then we graph this. Does this look right? Yeah, it looks right. Now here's one thing that I find with these types of rational functions that's pretty hard, is it's really hard to see this original and sort of figure out what the inverse is. And so it's just not as apparent as the other ones. What is our domain of this thing going to be? Well, we have,
Was that 1, negative 1?
yeah, that would be,
Excluding negative 1?
yeah, you exclude negative 1 from the original, which means
Oh,
that,
from the other.
from the original, but what that means here is that y cannot be negative 1, right?
X cannot
From the
be
original.
plus 2.
But x cannot be 2, so and what it is, we should see an asymptote at x equals 2, and we should see a horizontal asymptote at y equals negative 1, right? So we go back here, and we see a horizontal asymptote at y equals negative 1, that's from the original, and we see a vertical asymptote at x equals, looks like x equals 2, right? Yeah, that's what it was, right? X cannot equal 2. Yeah, that's right. So that works out. Now, I gave you a problem on the paper that I want you to write differently than what I have up here. And here's what I want you to do for number 16. Instead of the one I gave you on the paper, I want you to do this one up here.
Already worked that one out.
Yeah.
Did you already work it out? And you got the same thing, right? Did you get the same thing as the original and the one you worked out?
Oh, yeah, I did.
You should have got the same. I want you to do this one too. Okay, I appreciate you overachievers. You overachieving students. Let's continue to overachieve. That's how you establish greatness in your life. Yes. So this is what I ended up with here, 2x plus 3 over x minus 1, is that right? I could have made a mistake, but I didn't. And then you can check this. Again, I really have trouble seeing similarities. I know you have like a plus 3 here, but that's what the thing should look like. Did anybody graph those two of them too and kind of see the reflection pattern?
I'm showing where I messed up.
Excuse me.
Got that far.
Okay, one thing I did is I changed it, yeah, I changed it up there. Because the one you have on the computer is not the one you have up there.
Wait, so what would I do to pass this?
Well, here you have y is x minus 1, and you divide by x minus 1. So we have y, x minus 1. Oh, do you?
Because you gotta change it.
She was the same as the original computer one. 16. Jackson City. So you multiply through by y minus 1. So you get, okay, yeah, you get, what you get is you get xy minus x. And you have to add x to the side, so that's plus x. You see that?
Why don't we show how you do that?
Because
It's
look.
subtracted
Look,
together.
right here. Okay, and you multiply through. Okay, you have on the other side, you have x equals y plus 3 over y plus 1, right? Cross multiply, you have xy plus,
Very slowly.
that's a minus, right? That should be minus. So you have xy minus x equals y plus 3. And so you have, when you add x, see, that's where you get plus x. That's what it becomes plus. Because you had minus on this side, and add x to the other side. That's how it became plus on the right side. Okay. And again, our domain, we have, what's our restriction here? 2, right? And we know that y, when we do this, y cannot equal 2 either. So there we have it. Okay, did anybody do 17 yet? Okay, Kayla said she did it. You're working on it.
Can you come check, Mark? See if I got
17? Yeah, let's check on here. Okay, those are comfortable looking shoes.
Yeah, no.
Yeah, that is right. We're gonna have to worry about our domain a little bit on that day too. That's right. Boy, that was a good. Hey, you guys, volleyball team looks pretty good. You know who's really improved from last year in volleyball team? Somebody, I'll tell you, it's our setter. It's our setter. Because I don't care where she gets the ball, she puts it just 1 to 2 feet on our side of the net every time.
She's pretty good, yeah.
She's really, I mean, and she's better than last. She was good last year, but
She's been
she's
good every year,
but she's even better this year.
yeah.
And other people have improved too, but she's the one I've noticed more. But oh, of course, Emily's improved a lot from last year too.
Yeah. Yeah.
No, you guys should be a pretty good team this year. Okay. This one here, Emily worked this one out, and so you can correct me if I'm wrong on this deal here. I got, first of all, y equals square root of x minus 3, right? And then we go ahead and change this to x equals square root of y minus 3. And then solve for y. What do we do for that? Square both sides, right? So we get x squared is equal to y minus 3. And so y is equal to x squared plus 3. And so f negative 1 of x equals x squared plus 3. Now, we talked about domain restrictions, right? Do you have a restriction here? What's our restriction here? What does x minus 3 have to be?
0.
Has to be greater than or equal to 0, right? So x has to be greater than or equal to 3. And that's in our original. So that means when we go ahead and find the inverse, it's going to have to be y is going to be greater than or equal to 3, right?
Wait a second. Mr. G, I have a question.
Yes.
Okay, wait, so, wait, no,
Why wouldn't you square the 3?
Why would you,
or wouldn't you?
or why wouldn't you square the 3? Yeah, what happens is, when we take the square root here, we undo the square root, we just take care, this
Oh, yeah.
square root undoes this, and just leaves the y minus 3 intact. Was that your question?
Yeah.
Okay, that was a good question. That was really an excellent question, is what that was. All right. Now, here's where the restrictions come in, and really you have to sort of graph to see what happens here. Does anybody know what this square root of x minus 3 looks like? Well, it's the square root function shifted which direction?
To the right.
A la derecha, a la derecha.
So
Means to the right. A la derecha. So anyway, we have this right here. So that's, and that's what this looks like, right? And then we have y equals x, and then what do we come up with for Emily's answer here? This one here, right?
Yep.
So we got Emily's answer right here. And so this is what Emily's answer looks like right here. Okay? Now, are these inverses of each other? Well, then, not really, but part of it, right? And I misdrew it a little bit. It's this part, the inverse. So what it is, to have truly an inverse function, we have to go ahead and erase this left part of it. So for this, our domain is going to have to be what?
0.
Yeah, 0. So 0, infinity. Okay, which really, you kind of had to draw and sort of figure out what happens there, but that's that one, okay? And then, this one, 18, is very similar. You're gonna get,
Domain's the same.
pardon me?
Domain's the same.
The domain's the same as the last one? Yeah, domain would be the same as the last one, is what you're saying, Angel, is that right?
Yeah.
Yeah, this one here, you should get f negative 1 of x is equal to x squared minus 2, and then your domain restriction is going to be same as the last one, right? Okay, so that would be this one here. And for this one here, it's pretty easy to take a look at it and see what happens. You don't need me to work out steps on this, do you?
No, but give me a second.
Okay. Now, after this one here, the next 4 are cubic ones.
I got 9 minutes.
Yeah, so we'll be good. We'll be able to get through. These ones are really fast. In fact, I want to go to number 20. I'm going to work out number 20, and then you can work out 19, 21, 22. Okay, it's the same sort of thing here. So we come up here to the right, and we get y is equal to x cubed plus 5. And then we change like this, right? And then subtract 5. So we get y cubed equals x minus 5. And what is your undoing of the cube?
The cube.
The cube root. Okay, cube root of both sides here. So we have y is equal to cube root of x minus 5. And then we have finally f negative 1 of x is equal to cube root of x minus 5. Now, any domain restrictions here? Do we have any domain restrictions? No, we don't. No domain restrictions. Okay, so we have this. And the rest of those, 19, 21, and 22 are very similar.
How do you do cube root again?
I want to show it in the calculator, you mean?
Yeah.
Okay, yeah. Okay, I'm going to go ahead and erase these functions here. I'm going to show up. Okay, I'm going to clear this baby out here and clear. So we have, I want to show you, Angel, here. What we do is go to Math and 4. There will be that, right? So we get x, is it minus 5? So is it plus 5? Okay. It's plus 5. And up here, it's x cubed.
You good?
And that's going to be minus 5, right?
Yeah.
And then we graph right here, and we see these two functions that are inverses of each other. All right? Okay, so you should be able to do those other ones, 19 and 21 and 22 pretty well, right? Now, I want to go the ones on the back are very quick here. So we're going to do the ones on the back too, which are numbers 23 on. Okay, determine whether the function is 1-to-1. If it is 1-to-1, graph the inverse, okay? How can you tell if a function's 1-to-1? I don't remember if I talked about this.
It's the origin.
What'd you say?
It's the origin.
It's the origin? Well, not necessarily. You can be 1-to-1 without hitting the origin, but that's a really good guess. Okay, what you can tell is you're trying to find whether the inverse of a function is a function. How do you do that?
Vertical line test.
The vertical line test, but to find out whether the function is, the inverse is going to be a function, we do something called the horizontal line test. Because when we turn this thing into an inverse, does this thing pass the horizontal line test?
Yeah.
Yes, it does. So that means that inverse is going to be a function. And so we can go ahead and draw that. And what is the inverse of this thing going to look like?
The opposite direction.
Opposite direction. I'm going to try to draw it here, okay? So we have this like this. Let's see. Something like this, right? So that's not the best drawing I've ever done of this thing, but that's what it looks like. So whether the function is 1-to-1, yes. 1-to-1. And that is the sketch of the function, of the inverse function here. So that's going to be f negative 1 of x. Okay? Now, for problem 24, is this a 1-to-1? No, so not 1-to-1. What was the proof that's not 1-to-1?
It doesn't pass the horizontal.
Yeah, exactly, Angel. Okay, and Will. 1-to-1. I'm thinking of things while I'm writing something else. Fails horizontal line test. Okay? Fails horizontal line test. And then this 25, is this a function? Is this a one-to-one?
Yes.
Yes,
No.
one-to-one. And then what does that look like? Well, it's got to look like this. There we go. That was a better drawing than the first one I did. And then the last one here, is this one-to-one?
Yeah.
No,
That was horizontal.
not one-to-one. So fails horizontal line test. So we have that. So that's really it. Thank you, ladies and gentlemen.